All right, 2.5 is complex zeros in the fundamental theorem of algebra. The fundamental theorem of algebra says a polynomial function of x with degree n has n complex zeros, which can be real or non-real. Some of these zeros may be repeated. And so we had talked about this before. Remember, your degree is your n, it's your largest exponent, and it tells us the total number of zeros there are. And so they call them complex zeros because they can be the real zeros, which we've been dealing with before, or they can be the non-real zeros, which we're bringing in. All right, and we know that some of the zeros can be repeated because we talked about multiplicity. The linear factorization theorem says if f of x is a polynomial function with n greater than 0, then f of x has precisely n linear factors. And again, we already knew this because before, in like 2.4, if we said, well, our zeros were -4 and 2, then we said they gave us factors of x plus 4 and a factor of x minus 2. So because we had two zeros, that meant we had two factors. Well, the same thing here. My polynomial function is going to have the degree of n, which is going to tell me the number of zeros, which is going to tell me the number of linear factors. All right, then we can see that the fundamental polynomial connections in the complex case, we've already known this too. It says the following statements about the polynomial function f are equivalent if k is a complex number. So k is just some complex number. It could be 3 or it could be 3i. It doesn't matter. It's a complex number. Then we know that x equals k is a solution or a root of f of x equals 0. That k is a 0 of the function f and that x minus k is a factor of f of x. So it's just saying we've got this number x equals, and I'm going to use 4. They use the letter k. It doesn't matter. We know if x equals 4, then that's either solution or root. We know that that means that the 4 then would be a 0 of the function, and that if I put that back in with x, then that x minus 4 would be a factor of f of x. And it doesn't matter that the x minus k here isn't in parentheses. It can be, or it doesn't have to be because there are no other factors written there beside it. All right, and then it says suppose that f of x is a polynomial function with real coefficients. If a and b are real numbers with b not equal to 0 and a plus bi is a 0 of f of x, then a minus bi, its conjugate, is also a 0. So complex numbers, imaginary numbers, come in conjugate pairs. If I have a plus bi, then a minus bi is automatically going to have to be a 0. So if I have 2 plus I, then 2 minus I is automatically a 0. If I have 3i, then negative 3i is also automatically a 0. Now conjugate just means that we're going to change the sign that's in front of the I. We've talked about conjugates before with imaginary, and we've talked about conjugates before with radicals. So it's the same idea. They have the same pieces, different sign there in the middle. All right, so let's look at example 1. It says write the polynomial function in standard form and identify the zeros of the function and the x-intercepts of its graph. Well, so the first thing let's do is let's identify the zeros of the x-intercepts. All right, so we can pull them out of our factors. The x plus 2 is going to give us a -2. The x minus I square root of 3 is going to give us positive I square root of 3. And then the x plus I square root of 3 is going to give us negative I square root of 3. And you can see here that these are conjugate pairs. One of them is positive I square root of 3. One of them is negative I square root of 3. You're always, if you got one imaginary, you're going to have its conjugate as well. All right, so there's my zeros that it asked for. And it asked for the polynomial function in standard form. That means it wants us to multiply all these out. Now normally, well, we count. We got 3 different things being multiplied. You can see I have them underlined. Normally I say pick any 2. Okay, it wouldn't matter if you did the first 2, the last 2, or the outside 2. Any 2 would work, except when you have conjugate pairs, okay? So because I have these conjugate pairs, you want to multiply them together. Because the whole reason they're conjugate pairs is so that when you multiply them, the positive and the negative I square root of 3 will end up canceling out, or it'll become something else. I is going to disappear. All right, so when we go to multiply this, I'm just going to bring down for now that x plus 2. And then let's do FOIL on those others. You can do FOIL or the box. So we got x times x, which is x squared. We have x times positive I square root of 3, so it's going to be positive. And the x and the I on the outside of the radical, so we're going to multiply them together. It doesn't matter which one you put first. And then we have our square root of 3. And then on the inside, we have negative I square root of 3 times x. Negative times a positive is negative. Again, on the outside, we have I and x. Doesn't matter which one goes first. Since I put x first in the previous one, I'm going to do it on this one as well. And then we still have the 3 underneath the radical. And then the last, we have negative I square root of 3 times positive I square root of 3. And so I'm going to come over here and think about that. So negative I square root of 3 times positive I square root of 3. Remember, positive times a negative, I said it backwards. Negative times a positive is a negative. We got I times I on the outside, which is I squared. And then under the radical, we have the 3 times the 3, which would be 9. So I have a negative I squared square root of 9. And I'll simplify that in just a minute here. All right, so I'm just going to bring down this first part. I'm not ready to do anything with it yet. Times, I need to simplify this second parenthesis. And so here I have like terms. They're both xi. So xi square root of 3 minus xi square root of 3 cancels. So we have our x squared. We have a minus. Now remember, I squared, was equal to the square root of negative 1, and I squared then is equal to negative 1. So we have our minus, and then our I squared is a negative 1 times the square root of 9. Remember, always use the principal one, so it's 3. So again, I'm just going to bring down this first part. And I'm going to simplify here. So I have x squared. I have minus a negative 1 times 3. Well, negative 1 times 3 is a negative 3. So minus the negative 3 is going to make it plus 3. And now we're ready to multiply these two. So we have f of x equals x times x squared, x times 3, 2 times x squared, and 2 times 3. And then the only other thing we can do now, there are no like terms, but I do need to write them in standard form, so I need to put them in descending order of the exponents. So we end up with f of x equals, we have x cubed plus 2x squared plus 3x plus 6. And there is our polynomial in standard form. All right, so moving on, let's look at example 2. The direction says write a polynomial function of minimum degree in standard form with real coefficients whose zeros include the following. So on example 2, we can see we have the zeros of negative 3, 4, and 2 minus I. So I'm going to write these out here. So we got my zeros. It looks a little weird with all the parentheses and the brackets and stuff. So we know we got negative 3, 4, we got 2 minus I, and remember, if you got imaginary, its conjugate also has to be a 0, so 2 plus I is also a 0. So once we get our zeros, we're going to write it as factors. So I'm going to take the negative 3 and put it back in with x. We know everything changes signs when it goes back in with x, so it becomes a plus 3. The 4 is going to become an x minus 4. Now be careful here because you have a 2 minus I, so you're going to have your x, the 2 is going to change signs, and so is the I. Anything that goes in parentheses with x will change signs. So you got x minus 2 plus I, And then the 2 plus I gives us x minus 2 minus I. And so I know to write my polynomial in standard form, I'm going to multiply all these out. And so I'm definitely going to multiply my conjugates together here. And since I have 4 terms, I'm also going to go ahead and multiply those two together. So we have f of x equals, for the first one, we get x squared minus 4x plus 3x minus 12, doing FOIL. And so I'm going to go ahead and just simplify that below it. So it's x squared minus x minus 12, because I combine the like terms right there. Now, for my second parenthesis, this one's going to be a little tougher. So because it's 3 terms times 3 terms, I'm going to come over here on the left, and I'm going to draw me a box. And I'm going to use my little box to help me multiply. It's kind of like that Punnett square you do in science. So, all right, so it's a 3 by 3 because my equations are 3 terms and 3 terms. Doesn't matter which one you put on top or the side. I always just personally, I put the first one on top and I put the second one on the side. I just try to find a pattern that I use every time for it. All right, so I'm going to go through here. I'm going to start on the top left and go across and then work my way down. So I have x squared minus 2x times xi. I have negative 2x, positive 4, negative 2i. I have a negative xi, a positive 2i, and a negative I squared. Now remember, the nice thing about the box is your diagonals usually have your like terms. Very seldom are they going to be anywhere else. All right, so I'm going to change colors here. And so I look here, and I have my x squared. In my next column, I have a negative 2x minus 2x. That's a negative 4x. Now, when I look at that next diagonal there, I don't have all like terms. I have this 4 here, so I'm going to bring it over before I start dealing with my i's. Now, on the outside here, I do have a negative xi and a positive xi that will cancel each other. In the next diagonal, I have 2i minus 2i. Those also cancel each other. And then the last piece there, I just have a minus I squared. All right, so I'm going to rewrite this second one because I have x squared minus 4x plus 4 minus, and remember, I squared is a negative 1. So I'm going to bring down my first one because I'm not doing anything with it right now. But I need to simplify this second one. So I got x squared minus 4x, and then 4 minus a negative 1. Remember, minus a negative is a plus. So 4 plus 1 is 5. Notice when I do this, I didn't point it out on the other one when I multiplied the conjugates, but when I finish multiplying the conjugates, like right now on this one, notice I don't have an I in my answer, okay? If you're multiplying 2 conjugates together, the i's should all cancel out, so you should not have an I in your answer. All right, so we're ready to keep going. Now we got to multiply these 2. And again, this is going to be 3 terms times 3 terms. So I'm going to come over here and get me a box. All right, I hit something, sorry. So my box here, I'm going to have it 3 terms times 3 terms. So I need a 3 by 3. It's going to be the x squared minus x minus 12 times the x squared minus 4x plus 5. All right, I'm going to fill in my box here, same way I did before. X squared times x squared is x to the 4th. X squared times negative x is negative x cubed. X squared times negative 12 is negative 12x squared. Negative 4x times x squared is negative 4x cubed. Negative 4x times negative x is positive 4x squared. And negative 4x times negative 12 is positive 48x. 5 times x squared is 5x squared. 5 times negative x is negative 5x. And 5 times negative 12 is negative 60. So I'm going to go to write my answer here. All right, so I'm going to do f of x equals, see I have an x to the 4th And the diagonal here, I have a negative 4x cubed minus x cubed, which is a negative 5x cubed. All right, the next diagonal, I have 5x plus 4x, I have 5x squared plus 4x squared, which is 9x squared, minus 12x squared, which is negative 3x squared. The next diagonal, I have 48x minus 5x, that's 43x. And then finally in that last box, I just have my minus 60. So there's no like terms to combine. My exponents are written in descending order, so here is my polynomial in standard form. Now, I should have known it was going to start with my degree was going to be 4, because at the beginning we had 4 zeros and we had 4 factors. So we knew we should have started with that x to the 4th. All right, let's try example 3 then. So in example 3, I can see I have x equals 1 as a 0 that has multiplicity of 2, and I have x equals 1 minus I as a 0 that was given. All right, so let's talk about our zeros. So we said we had x equals 1 multiplicity of 2. That means it's there twice. And then we had 1 minus I as a 0, and that's a complex number, so we know that 1 plus I is also going to be a 0, because remember they come in conjugate pairs. So if I'm going to write out my factors here, I have 4 zeros, so I should have 4 factors. The plus 1 is going to give me x minus 1, and then I'm going to have x minus 1 for the second one. The third one, the 1 minus x, is going to give me x minus 1 plus I. And then the last one there, the 1 plus I, is going to give me x minus 1 minus I. All right, so now we're ready to find our polynomial, so we're just going to multiply all these out. So we're going to multiply these two together and these two together. So the first one, we're going to get x squared minus x plus 1. If we're going to simplify that, it gives me x squared minus 2x plus 1. Now my next two, that's 3 terms times 3 terms. So I'm going to come over and do my square again. It's going to be a 3 by 3 because it's 3 terms times 3 terms. I got x minus 1 plus I times x minus 1 minus I. Alright, so I get x times x, which is x squared, x times negative 1 is negative x, and x times I is xi. Negative 1 times x is negative x, negative 1 times negative 1 is 1, negative 1 times I is negative I. Negative I times x is negative xi, negative I times negative 1 is positive I, and then negative I times positive I is negative I squared. So when I go to bring these out, I have x squared. Then we have negative x minus x, which is a negative 2x. I have that positive 1. Then I have xi minus xi will cancel. I minus I will cancel, and then I'm left with that minus I squared. So I need to simplify up this second parenthesis. So I got x squared minus 2x plus 1 minus, and remember I squared is a negative 1. And so I still need to clean up the second parenthesis a little bit. So I got x squared minus 2x plus 1 still in the first one. And then we got x squared minus 2x. And then we got 1 minus a negative 1. Remember, minus a negative is a plus. So 1 plus 1 is 2. And now we just need to multiply these two trinomials together, or 3 terms. And so we have x squared minus 2x plus 1 times x squared minus 2x plus 2. So x squared times x squared is x to the fourth. X squared times negative 2x is negative 2x cubed. X squared times 1 is x squared. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 2x is 4x squared. And negative 2x times 1 is negative 2x. 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. And 2 times 1 is 2. So for my answer here, I'm going to get f of x equals, I have an x to the fourth, then I have a negative 2x cubed minus 2x cubed, which is negative 4x cubed. We have 2x squared plus 4x squared, which is 6x squared, plus 1x squared, which is 7x squared. Negative 4x minus 2x is negative 6x. And then we have our positive 2. Alright, my exponents are written in descending order. So here is my polynomial in standard form. Alright, but what happens if they just give us a polynomial now and they tell us to find the zeros and to factor it? Well, that's what they're going to do here in example 4. So it says find all the zeros of f of x equals x to the fifth minus 3x to the fourth minus 5x cubed plus 5x squared minus 6x plus 8, and then factor it over the set of the complex numbers. Well, remember, if they don't give us a zero and we can't factor it out, then we're going to have to use our p's and q's. So on this one, my p's are going to be the factors of, remember, it's always the constant, so 8. Which are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Our Q is going to be the factors of the leading coefficient, which in this case is a 1. So it's just going to be plus or minus 1. And so our P over Q's, and we take every P and divide it by every Q, we're going to get 1 over 1, which is 1, 2 over 1, which is 2, 4 over 1 is 4, and 8 over 1 is 8. And then we have to pick one to try. But we had talked about prior to Thanksgiving break that we would use our calculator to guide us. We're still going to show our synthetic division. We're still going to show that it works. And we're also going to bring this down to x squared so that we can either factor or we can use our quadratic formula to finish solving it. Alright, so we're either going to choose one or use our calculator to help us. And so the first one I'm going to choose is, I don't know if y'all are seeing what I'm seeing or not. I lost it on my computer. Let me try to pull this back up. There we go. So I'm not sure if my computer loses it, if y'all can see it or not. So wanted to make sure on that. Alright, so we're going to pick one there and let's try a 1. So when I try 1, I'm going to use synthetic division. So my coefficients are 1, x to the fifth, minus 3, x to the fourth, minus 5, x cubed, plus 5, x squared, minus 6x, and then a positive 8. Remember, if we were missing any of those terms, starting with that x to the fifth all the way down, then we would have to put a 0 as a placeholder. Alright, so bring down your first term. Anything on the bottom row gets multiplied by the box. So 1 times 1 is 1. Combine them, negative 3 and positive 1 is a negative 2 times 1. Combine them, times 1. Combine them, times 1. Combine them, times 1. And combine them. And yay, we got 0 as a remainder, which meant that 1 is a 0. And so I'm just going to come over here right now, and I'm going to make a list of my zeros. And we found that 1 is one of them. So now we're going to find another 0. And when we do, we're going to use the coefficients that we just found. Because remember, we started out with x to the fifth, so this starts out with our x to the fourth. So this is x to the fourth minus 2x cubed minus 7x squared minus 2x minus 8. And so we're going to pick another one to try for our 0. And let's say we're going to try the number 4. And now I'm going to use these coefficients. I want to do that because I want to bring my answer down to x squared. Alright, so let's do our synthetic division here. And yay, we got 0 again. And so our answer out of this one then is x cubed plus 2x squared plus x plus 2. So we know then that 4 was a 0, so let me put it in my list up here. And we're going to do this one more time so that we can bring this down to x squared. So we got to pick one more number out of our list that we hope is going to work. And so we're going to try a -2. My coefficients are now the 1, 2, 1, 2. So bring it down, multiply, combine, multiply, combine, multiply, combine. And this one worked again. It was a 0. So we know that -2 is also going to be a 0. And then we're left with, this 1 is going to be my x squared. So we got 1x squared plus 0x plus 1. Now if I'm going to use quadratic formula to solve this, I'm going to use this. But we know that 0x means it doesn't exist. So this is the same thing as saying x squared plus 1. Either way, these would be set equal to 0 to solve. And because we don't have an x term, we only have x squared, we can just algebraically solve this by moving the 1 over and taking the square root. But if I'd had an x squared and an x, I would have to use the quadratic formula or factor it. Alright, so let's move the 1 over. And so when I do that, I got x squared equals -1. Solve for x by taking the square root. So x equals, remember you take the square root, you get plus or minus, and the square root of -1 is I. And so there's my other two zeros. I have a positive I and I have a negative I. And so we knew by looking at that leading term, it's x, the degree of this polynomial is 5, which meant I expected 5 zeros. And if you count them, 1, 2, 3, 4, 5, we have 5 zeros there. So here are my zeros. And then it wanted us to factor it over the set of the complex numbers. So it wants us to put all our zeros into factors and write f of x in front of them. Alright, so, dang, I'm kind of out of room, but let me change colors. I think I can squeeze this in. So, we would write f of x equals, the 1 gives us a factor of x minus 1, the 4, x minus 4, the -2 is x plus 2. I'm just going to write it below it here, but it would be written out to the side as well. And then the I would be x minus I, and the negative I would be x plus I. And so here is our polynomial in factored form. That is the factor over the set of the complex numbers. Alright, example 5. Says a complex number z equals 2i is a 0 of the polynomial. Find the remaining zeros of f of x and factor over the complex numbers. So we're doing the same thing, but this time they gave us one of the zeros. Alright, but I can't do synthetic division with an imaginary number. I don't want to put I in there because then it's going to get really, really confusing. But, so let's think about this. They told me a 0 was 2i. And so we know then -2i is also a 0, correct? Which means then I know that we have factors so far of x minus 2i and then x plus 2i. Well, I can't divide those individually into this polynomial, but because they have I in it. But if I multiply them because they're complex conjugates, remember our I is going to disappear. So when I multiply these, I'm going to get what they call a quadratic factor because it'll have an x squared in it. And that's not going to have an I in it. And I can use it then to divide to help bring this polynomial down some. All right, so let's go ahead and multiply this. So I'm going to do my FOIL. And so we get x squared. Those two cancel, minus 4, and remember I squared is -1. So we end up with x squared plus 4. So now I can take this polynomial, and I can divide it by the x squared plus 4 to find another quadratic polynomial that I can either factor, or I can use my quadratic formula, or I can just solve it using the square root theorem if there's no x in it. Alright, the only thing is, notice this time we're dividing by an x squared plus 4. And because it is x squared, that means we cannot use synthetic division. So we're going to have to use long division. Alright, so let's set it up. I'm dividing by the x squared plus 4. So on the outside, I'm going to put x squared plus 0x plus 4. Because remember, if anything's missing, you need to include it. From the largest exponent down to no exponent. Or down to no x. Alright, on the inside, I have that 2x to the 4th plus the x cubed minus the 7x squared plus the 4x minus the 16. I didn't have any terms missing there. Alright, so I know it's been a little bit since we did long division, so I'm going to walk you through it. Remember, we divide the first term, so 2x to the 4th divided by x squared. So if you need to, write it out to look at it. X fourth divided by x squared is x squared, and we still have the 2, so we get 2x squared. Then we're going to multiply whatever we put there by this entire outside. So we're going to take that 2x squared, and we're going to multiply it times x squared plus 0x plus 4. And we're going to put that right here underneath its like terms. So distribute, so 2x squared times x squared, 2x squared times 0x, and 2x squared times 4. Now remember, we're going to subtract, which means we're going to change all the signs, so that becomes negative. This is going to become negative, and this is going to become negative. Then we combine them. 2x to the 4th minus 2x to the 4th cancels. Your first term should always cancel. We got x cubed minus 0x cubed. Still have an x cubed. Then we got negative 7x squared minus 8x squared, which is negative 15x squared. And then we're going to bring down the rest. Then we're going to repeat. So we've got x cubed divided by that x squared on the outside. So x cubed divided by x squared is x. Then we're going to multiply that x times everything on the outside. So we got x times that x squared plus 0x plus 4. And just like before, we're going to put that underneath what we just had. So distribute x times x squared, x times 0x, and x times 4. We're going to subtract, so change all the signs. And then combine. X cubed minus x cubed cancels. Negative 15x squared minus 0x squared is still negative 15x squared. 4x minus 4x cancels, but I'm still going to put a 0x there for a placeholder and bring down the rest. And then we're going to do this one more time. So we have negative 15x squared divided by that x squared on the outside. So negative 15x squared divided by x squared, we get minus 15. We're going to take that times everything that's on the outside there, so negative 15 times the x squared plus 0x plus 4. Distribute. So we got negative 15x squared plus 0x minus 60. We're going to subtract it, which means change all the signs. Negative 15x squared plus 15x squared cancels. 0x minus 0x cancels. Negative 60 plus 60 cancels. So we have no remainder. And we should have known we were not going to have a remainder, because if x squared plus 4 was a factor, it means it divides in evenly. And we knew x squared plus 4 was a factor because it came from the x minus 2i and the x plus 2i, which were also both factors. Alright, so what we've done here now is we found that we've got 2x squared plus x minus 15 is a factor as well. So I'm going to bring that down. So 2x squared plus x minus 15, and my other two zeros are in this problem. So now we need to choose. Do we want to use, see if we can factor this. We can use the quadratic formula, And we can't use that square root theorem, though, because we have an x squared and an x. So I'm going to try to factor this, which this one is factorable. So I'm going to do my first times my last. And that gives me x squared plus x minus 30, which is x plus 6 and x minus 5. Do that to multiply to 30, but subtract to 1. And don't forget, because you multiplied by the 2, you got to divide it back out. So we get x plus 3 as a factor. And then I know we're still solving it equals 0, but remember, you cannot have a fraction or a decimal in a factor. So you simplify it if possible. 5 over 2 doesn't simplify. And then if it's still a fraction, the number on bottom goes in front of the x. So 2x minus 5 equals 0. And then we'll clear me a little room over here to finish this, because now we know that we're going to set these individually equal to 0 and solve for my zeros. So x plus 3 equals 0, and 2x minus 5 equals 0. Subtract the 3, so we get x equals negative 3. Add the 5. 2x equals 5, divide by 2, and so x equals 5 over 2, or you can put 2.5. As a 0, it's okay. As a factor, it is not. Okay? So, I'm going to erase some of my synthetic division, my long division here. So I'm just going to erase all of it, so I can get myself a little room to write my answer here. Alright, so, now we can find our answer. We know our zeros. How many zeros should we have? Well, it's a 4, degree of 4, so I should have 4 of them. We have 2 of them from over here, the 2i and the negative 2i, and then we found our other 2 down here. So we said it was negative 3 and 5 over 2. And then it wanted us to write it as a factor, so we're going to have, let me go ahead and box this because this was my zeros. And so the factored form is f of x equals, we got x minus 2i, x plus 2i, x plus 3, and then remember, we can't have a fraction, so this number has to go over there, so instead of using that, we're going to use 2x minus 5. And so this is my factored form. And you didn't actually have to write the x minus 5 halves, because remember, we had already said we were doing the factors over here. We had also already said these were the factors, so we could have just grabbed them as well. Alright, so there's our answers. Alright, so example 6 is kind of the same. It wants us to write, well, it's kind of the same as 4 actually. It wants us to write f of x equals 3x cubed minus 2x squared plus x minus 2 as a product of linear and irreducible quadratic factors, each with real coefficients. That is, it wants us to factor over the real numbers. So what's going to happen is it wants a factor over the real numbers. When we get to a quadratic, it's going to give us imaginary numbers. And therefore, it's telling us stop. Now, if you go ahead and you give the imaginary numbers, as long as you got the quadratic one above it, I'm going to take it, okay? So I know it's kind of hard sometimes to know when to stop. But let's go ahead and we'll do this, and I'll show you where to stop at. So we're still going to have to do our p's and q's. So our p is the factors of the constant, which is a 2. So we got plus or minus 1 and plus or minus 2. Q is the factors of the leading coefficient, which is a 3. So we get plus or minus 1 and plus or minus 3. Well, I'm thinking about it, that last number is actually a negative 2. And so I put just positive 2, but does it really matter? It doesn't, because the factors of negative 2 are the same as the factors of positive 2. All right. And so for my p over q's, we're going to take every p over every q. So I'm going to take my first p. Well, I'm going to take both my p's and put it over my first q, and then both my p's over my second q. So I get 1 over 1, and I get 2 over 1, but then I get 1 over 3, and I get 2 over 3. Alright, so I need to pick one to start with, and so let's try a positive 1. Now remember, I expect how many zeros total? I should have 3 of them, and since I know by the directions one of these is going to be an irreducible quadratic, I only needed to find one that's going to work. Alright, so I've got 3x cubed minus 2x squared plus x, and then minus 2. Bring down your 3 times the 1, combine them, times the 1, combine them, times the 1, combine them. And we get 0 for our remainder, which means we have 3x squared plus x plus 2 equals 0. Now, if I try to factor this, I would have x squared plus x plus 6. There's nothing that multiplies to 6 that will add to 1. Be careful, because some of y'all are thinking, well, 3 and 2. So if I tried 3 and 2, but look, when I go to multiply, 3 times negative 2 is a negative 6, and I needed a positive 6. So I can't factor this, okay? So if I try my quadratic formula, x equals negative b plus or minus square root b squared minus 4ac. Sorry, I didn't write out my a and my c and all that, so it takes me a second. All over 2a. This is where something's going to happen in that radical. So let's just focus on it, okay? So in that radical, we would get the square root of 1 minus 24, and that's equal to a negative 23. Because we get the square root of the negative, that's where we know it's imaginary. So if you wanted to go ahead and work this one out, you would have had x is equal to negative 1 plus or minus I square root of 23 all over 6, okay? And so you would have had 2 zeros, and that would make it hard to write it in that factor. You'd get your 2 zeros there, the negative 1 plus and the negative 1 minus, but it makes it hard to write it. I'm not saying we can't, but it's just a little harder because it's over 6. So what they had said here in the directions is if it's irreducible quadratic, so you're not going to get any real numbers, then stop there, okay? So this is going to be one of our factors. So when I go to write this, it's going to be f of x equals that 3x squared plus x plus 2 times, what was the 0 we found that gave us that? The 1. So it would be x minus 1. And so this is the product of the linear and irreducible quadratic factors. All right. And so 7 and 8, or example 7, is just really review. Let's talk about it real quick here. So it says sketch a graph of the polynomial function with the given zeros, multiplicities, and the sign of the leading coefficient. So it tells us it has a 0 at negative 3 with multiplicity of 2, a 0 at 4 with multiplicity of 3, and our leading coefficient is greater than 0, which means our leading coefficient is positive. So when I go to graph this, it told me I have a 0 at negative 3, with multiplicity of 2. Now remember, multiplicity of 2 means that it's really there twice. And we had talked about even an odd multiplicity, and doesn't mean is it going to cross our x-axis or is it going to touch and turn. Remember, 2 is even, and even is going to touch and turn. Then we have a 0 at 4. And it has odd multiplicity, so we know it's going to cross. Now our leading coefficient is positive. And we need to know our degree, because remember, we got to find out what the end behavior is doing here. Well, our degree is how many zeros do we have? Well, I have 2 of them that are negative 3, and I have 3 of them that are 4. So let's see, if I wrote it out, it'd be negative 3, and then 4, 4, and 4. So there's 5 of them total, isn't there? 2 plus 3. So that means my degree is going to be 5. So I have an odd degree, so they're going in opposite directions, with a positive leading coefficient. So I know that it's going to look something like this on the ends. So I know it's going to fall left and rise right. So looking at my graph there, and it's going to fall left. So on my far left 0, I'm going to let it fall, going to the left, and it's going to rise to the right. So my far right 0, I'm going to let it rise. Now what's happening in between is going to be based up here. At the negative 3, we said it was touch and turn. So let me change color so we can kind of see it here. So as I'm coming to that negative 3, it's going to touch it and it's going to turn. So now we know it's going to go down here somewhere, and obviously it's going to have to come back, okay? And then we can see here when we go to the positive 4, we had said it was going to cross it, and we can see that it doesn't. Now, I purposely made mine have this little shape right there because it had the multiplicity of 3, which is a cubic, so it should have a little cubic shape. But if you draw it straight through there, guys, I'm going to accept it. It's fine as long as it crosses. And you can check this because you could write out your factors here, okay? You could say we're going to have x plus 3 squared, and we're going to have x minus 4 cubed, and we know it was a positive number here, so we're just going to pretend it's a positive 1, okay? If I find my y-intercept, which is where we let x equal 0, it'll tell us at least if it should be positive or negative. And so when I do this one, I'm going to end up with 0 plus 3 squared times 0 minus 4 cubed. And it was a positive 1 here at the beginning, remember, but I'm not going to put it because 1 times anything is itself. So we end up with 3 squared times negative 4 cubed. So 9 times 64, negative 64, excuse me, which is like a negative, do I have it written down? I think I did. Let me get to the page. A negative 576. So that doesn't necessarily mean, because we don't know what A is, we don't know if it's a 1 or is it a 5 or is it a 200. But we know that our y-intercept is negative, and we can look at our graph and see that yes, it is negative. Notice I didn't put a scale on that y-axis. I didn't put any dashes or tick marks on it, okay? I didn't scale it, so as far as we know, that's exactly where it's supposed to be. All right, and then the last one there. Example 7b. So we have a 0 at negative 1 that has multiplicity of 2. We have a 0 at 3 that has multiplicity of 2. And our leading coefficient is less than 0, so it's going to be negative. So remember, multiplicity of 2 just means it's there twice, which means it is even, so it's going to touch and turn. So let me go ahead and put my 0 at negative 1. And then here we get 0 at 3. It's got multiplicity of 2, so it's also going to touch and turn. All right. Now, we said our leading coefficient, it said it is less than 0, so that means it's negative. And my degree, well, I have 2 of them here and 2 of them there, so my degree is 4, which is even. If my degree is even, that means they're going to go in the same direction. Either both ends are going to go up or both are going to go down, but because it's negative, we know they're both going to go down then. So we're going to fall left and right. So I'm going to go to my 0 that's furthest on the left, and I'm going to fall out of it. I'm going to go to my 0 that's furthest on the right, and I'm going to fall out of it. And then go back up to your multiplicities. Remember, the negative 1, it's a touch and turn, so it's going to touch, and it's going to come back down. But it's got to come back up to this other one. And then we can tell, looking at it, it's going to touch and turn, and then check real quick over here. Is that what it was supposed to do? Yes, it was. Now, is my y-intercept negative? Let's check real quick. So that first 0 gives us a factor of x plus 1 squared. The second one gives us a factor of x minus 3 squared. And we know our leading coefficient is negative, so I'm just going to put a negative there, or a negative 1. So we have negative 0 plus 1 squared times 0 minus 3 squared. Remember, I put in zeros because I'm looking for the y-intercept. We get negative 1 squared times negative 3 squared. So that's what? Negative 1 times 9, which is, am I right it above here? So it's a negative 9. So my y-intercept is negative, which is what I'm showing in my graph. So we've probably got it correct then. All right, guys, that's the end of 2.5.